So if you go to page 2 of your notes, go down just a little ways, you'll see the beginning of lesson 6-2, simplifying algebraic expressions. A term, it could be a number, a variable, we can call that a letter, right? Or we can put the number multiplying a letter. So that's what it means by a product of a number and one or more variables. And it looks just like this negative 5x. This would be a term. It's a number multiplying a variable, right? But it could also just be a number, and it could also just be a letter sitting there all by itself. Now let's take a look at an example of like terms, and then show you some examples of terms that are not like. And this will be right on your notes there, and just go ahead and copy them down. Each class period, I had some minor variations of these examples. Just make sure that you've got them filled in, and normally we have an extra one down here that I'll have you write in from scratch right in there, okay? The reason that we would say that 5 and 3 are like terms is that we could actually add them together, and you could think of it as being on the same team. Now over here, this is a negative 5. We don't worry about it being positive or negative. What we worry about is that there's a letter attached to the number, and 8 doesn't have the same letter attached. So we would be like, hey, these are not on the same team. We can't add them together, okay? They would not be cooperating. There would be a little bit of a difference there. So let's go look at some other examples here. If we saw that 2 was multiplying x, this would be a term, 2x. It would only trust another number that had an x with it. So 3x, yeah, these two could get along because they're on the same team. Over here, though, if we went over to this side, I would say that 2x would not get along with negative 3y. And it has nothing to do with this being a negative. It's not a positive negative situation. It's that this has an x, and it only trusts other numbers that have an x. This has a y, so they can't trust each other, so they are not like each other, right? Like terms have the exact same variable and the factors on there. Let's come over here and let's take a look at this part right here. What about if we had a negative 2 timesing an x to the second power? Well, if it was another number or x to the second power, they would get along. See, so we could trust them. They could trust each other. But over here, if it was like, 4 times x and it was a negative 3x, yeah, they would get along. But if I stuck a y behind this x, this y means that this 4x can't trust this negative 3xy, so they could not be added together. They are not like terms, and that's why we have it over here on this situation here, okay? Now, let's go and add this on real quick. I know you're going to have to squeeze this in here, but there's a little bit of space before you see the combined like terms part there, right? So let's come down here and just squeeze this in. A 4xy would absolutely be able to combine with negative 8xy. And now let's come over here and do one last example over here. How about 2x to the second and 5x? That's the situation. This does not have x to the second power, so these two cannot get along. Now, we know what like terms are, but now we've got to practice actually combining the like terms. And I've always told my kids, it's like cleaning up a messy room. You'd want to put all of your dirty laundry that's probably, flung all across your room. You'd want to get that all into one spot, put it into your hamper, suddenly your room looks a lot cleaner. But then you probably see some dirty bottles and other trash laying around the room. You'd want to gather all of that trash up, and you wouldn't want to put it in the same spot. You'd put the trash in a trash bag or a trash can off to the side, and so we'd get like, two different locations, and everything has to go to its place. And that'll make more sense in a second. So you came in, this problem is messy. We have two different numbers here. How about we just put them all in the same spot? They're like terms. 5 plus 3 equals 8. Hey, we just cleaned up this room. Instead of having two numbers there, we just see one. How about 2x plus 3x? Well, they're like terms. Instead of writing it like that, how about we just go ahead and add them? 2x plus 3x is 5x. You just add the numbers, and then you just keep the x on the end. Same thing's happening right here. They're like terms because they both have x to the second power. No problem. So negative 2 plus 5 is 3x to the second power. Now, do you remember in our lesson yesterday that whenever we saw subtraction, we would want to turn it into a plus the opposite? Well, I want you to do the same thing for this too. So 4xy plus negative 8xy equals negative 4xy. That way you're still doing the same thing that we were doing yesterday. Now over here, for this situation, the idea is that anytime that you see a letter here, a variable, without a number multiplying it, slide in a 1 and it'll make it so much easier so you don't make the mistake of just saying, hey, this is 14m. Well, no, it's 5m plus 9m plus 1m, which is 15m, okay? A lot of times what I'll see is that people don't put the 1 there, and then they just tell me that the answer would be 14m. Or they'd say 2x, and they go ahead and they make this into add the opposite plus the opposite, but they would say 2x plus negative 17x is negative 15x. Well, the problem is that this x doesn't have a number in front of it right there to put that 1 in there. Oh, so let's see this right here. See, that would be a 3x plus the negative 17. Now I'm going to erase this that way we can have a little bit of space here. 3x plus negative 17 would be negative 14x. Okay? So if the instruction said please combine the like terms, or if they said simplify the algebraic expressions, that's what we're doing here. Now, I'd like to add on a special problem here real quick. If you could just make a little space at the bottom of page 2 there and just call it special and put a little box there. We're still going to be combining like terms, but I want to show you when one of the terms is not like the others. So 3x minus 8x plus 3. Well, you know what we need to do. If we see a subtraction, go ahead and make it into plus the opposite. Well, 3x plus negative 8x, that is negative 5x. Okay, this combines with this. They are like terms. The problem is that you can't say negative 5x plus 3 it's negative 2x because this doesn't have an x on it. They are not like terms. And so when that happens, they just sit beside each other, and that is completely okay. We never asked you to go solve for what x is. You don't have enough information. We're literally just telling you, go clean your room up. Or in this case, go clean up the problem for us. It looks messy. So that's all that we're doing. See how it's an improvement? It's not so long. It's a little bit shorter. It's not perfect, but it helped us clean up the area. And that's what I'm trying to tell you over on page 3. Sometimes you'll see parentheses in a problem. Use the distributive property to get rid of parentheses before combining. We're going to clean it up. And then right here in bold is what I just told you on the bottom of page 2. Remember though, you can only combine like terms. If they're not like, they just sit there beside each other. Combine the like terms. So here's an algebraic expression. We're not telling you to go find out what C is. That would be solve. We're not telling you to solve. We're saying combine like terms or to simplify, right? That's all that we're telling you to do. The first thing that we would do is the same thing that I've been telling you since the last lesson is if you see subtraction, please go turn that into a plus the opposite. So this is going to change into a plus, and that would be a negative 3. Now, I'm going to get my highlighter out here just that way we can see this real quick. This 8c and the plus is just sitting there, and so we're going to go ahead and just write that. After you get rid of any subtraction, what you do is you have to get rid of the parentheses before you can combine like terms, okay? And so now we look at this number, the negative 3 that's right beside the parentheses, and we're going to multiply it by everything that's inside of the parentheses. So negative 3 times c is just negative 3c. The plus sign is just like the 8c plus. The plus sign right here is going to fall straight down. And now we're left with negative 3 again, timesing 5, which is negative 15. That's all we do. Okay, you're going to see it again and again, so don't be concerned if you're having a little trouble following along here. And now we're going to clean up our room here. Are there any like terms? 8c plus negative 3c. See how we're using the signs to the left of it? And now, since they both have c's, we're just going to say what's 8 plus negative 3? Well, it's 5. And I'm going to write that right underneath the first term that I used to combine. They both have C's, so they get a C with it. And now this is gone. And then see, this makes us another little box scenario where the plus negative 3C is gone. And the plus negative 15 that doesn't have a C right here just falls down. And that is your answer. That is your simplification of that big algebraic expression up here with the parentheses. So let's go through and let's do this one real quick right here. Here's 11 minus 2, parentheses, 3b plus 1. Make this into and add the opposite. Okay? Let me clean my screen up here again. All right, the 11 plus can fall straight down. Now, what's going to happen here is that the negative 2 is going to multiply the 3b, so that becomes negative 6b, right? The plus sign here falls down, and then the negative 2 times the 1 is negative 2. And now we just come through and we try to combine where we're able to. Now this 11 can't be combined with the plus negative 6b, but it can combine with the plus negative 2. See, they don't have letters. So 11 plus negative 2 is 9, and I'm going to write that right here, and then I can pull down the plus negative 6b right behind it. Now, is this the only method of where and how we write these things after we combine them? No, but it's just my habit that when we use two things to combine, I'll write what the new combined answer is underneath that first term we used. Everything else just falls wherever it was in the problem, and it keeps things nice and neat. Let's go through and let's do the last two together, and that'll wrap up this lesson here. We have subtraction right here, so add the opposite. We have subtraction here, add the opposite. 7x and the plus sign are free to drop. And now it's negative 2 times x, so we write negative 2x right here. And then we write negative 2 times negative 3 is positive 6. But see this plus sign? That just drops straight down. And now we're free to combine these two to get 5x. And then the plus 6 falls straight down. Let's come over here. I see that we have subtraction in two different places on this problem, so we'll go ahead and add the opposite. When you're using a worksheet and there's not a lot of space on there, you might want to put a plus here, and then just put that negative sign up high. It makes it easy so that way you know you added that in yourself. Let's go ahead and drop down the 5 plus. Now, I like drawing the jump lines here so we can see for the multiplication. Negative 3 times x would be negative 3x. This plus sign right here would just fall straight down, right? And then the negative 3 times the negative 8, well, negative times negative is positive, so that's a plus 24. And then we can let the plus 6x sitting down here at the end of the problem fall straight down. So again, if you see subtraction, make it a plus opposite, then use this number right against the parentheses to multiply everything inside the parentheses. That plus sign or whatever will fall straight down. And then you just check to see if you're able to combine anything. You're not always able to, so don't be shocked if you can't. 5 plus 24, see how these two are going together? So I'm going to put the 29 underneath the 5. And now I'm going to say, hey, negative 3x, since that's the first term I'm using to combine with this back here, negative 3x plus 6x is 3x. So I'm going to put that right underneath it. But look at this plus sign that wasn't used. We can fall straight down with that. And that is our final answer. Once you get through these steps, you won't make a lot of mistakes. To recap though is pretty much I need you to be able to combine like terms from today's lesson. Also, anytime that you see a subtraction sign, I need you to turn it into a plus opposite. That's not new now. That's not new. And then use the distribution property, the distributive property, to get rid of those parenthesis signs on those long, harder ones before you do any combining. And we just use multiplication. It's different than adding. We use multiplication to get rid of those multiplication symbols. Excuse me, the parentheses. It's a Saturday. See you guys.